A vertical tower stands on a horizontal plane. So let's go ahead and draw a horizontal plane. A vertical tower it's okay if it's a building. A vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff, or mounted by a vertical flagstaff. Vertical flagstaff. And it tells you that by a vertical flagstaff of height 5 meters. So they're saying that this part here is 5 meters. At a point on the plane, so the horizontal plane, purple and purple, the angle of elevation to the bottom, the angle of elevation of the bottom and the top of the flagstaff are respectively 30 degrees and 60 degrees. So it kind of gives you both. The angle of elevation of the bottom is first 30 degrees. That's what they're kind of telling you. So the angle of elevation of the bottom and the top of the flagstaff, so the let's see if we have that right. That would be the bottom, so that one should have been a smaller degree. That one should have been here, sorry. That's 30 degrees. And to the top of the flagstaff would be 60 degrees. So from that same point, it's now pay attention. I'm gonna go from this segment all the way down here. That one's 60 degrees. Let's see if I can do this. I don't think. So I'm using this measure app. And if you do a level, it's hard. Let's see if I put my phone flat, it gives me 0 degrees. But if you tilt it up, which one, if I just tilt it a little bit, let's just say I'm measuring the height of this projector that's over here. How many degrees do you think it'll be? A lot or a little? A little. Right? Take the absolute value, like 7 degrees. Okay, it's shooting out, making a triangle over here. Does this make sense? So when you're far away, the angle is actually kind of small. Now let me say that again. I know the projector's right next to me, but if you're super far away, right? Like we're far away from, say, the soccer field, the angle of elevation of the goal, the soccer goal, is going to be the angle is going to be very low. But if we run up to the soccer goal, what do you think the angle is going to be? Small or big? If you're right next to it, right? You're lying on the floor in the grass, the angle is going to be super high. Okay, so this idea is going to be super helpful for you, not only for your projects, but to help you understand these word problems. Okay? All right. Find the height of the tower. So they want to know the height of the tower here. They want to know just the blue, right? So now let's go ahead and take our triangle and let's separate into two triangles. Obviously, they both have the horizontal plane, the ground, in purple. They both have that, right? Okay. I'm going to call this the small triangle. SM, small triangle. And that's this triangle here. See it? So class, is this red and blue or just blue? So the small triangle is just blue. And we have an angle of how many degrees? 60 or 30? 30. Uh-oh. You guys seeing it? We want to solve for x. Yes? But what's missing? You can't use trig ratios because although you have an angle, right? Trig ratio, angle, and then two sides. Do we have a second side? No. No, it's an unknown. Now, let's draw the second one, and maybe this will help us. I think I switched them, it's okay. Big, this is my big. The big triangle has this as what is the side? What colors? Blue and red. Blue and red. And the orange. Okay, now pay attention. Here's your geometry. Let's see. Based on the big triangle here, the length of the big side is called? Remember, it's segments. Yes? Yeah. You add segments. Class, would it be 5x? That would be multiplying. So it's going to be what? X plus 5. Because this is 5, this is x plus 5. And then you guys said the orange, this would be 60. Okay, what's helpful for us here? What does it have in common, the two triangles? They're exactly the same. Okay, the 90-degree angle. What else? Okay, they both have 30, 60, 90s. I like that. But remember now, we're missing a side. They both have what color in common? Now this side is a blue, but this one's a blue and a red. So the side they have in common is the purple. I'm going to call it Y. Talk to your partner. What happens in algebra when you're trying to solve for two variables? Ready, set, go. You guys know what that's called? A system. Systems of linear equations. So let's go ahead and make a equation for our small. From this angle, class, you have which sides? Opposite. And hypotenuse, and then this one is the adjacent. Okay. Which one are we not going to use? Hypotenuse, because there's no variable or number. So class, which trig ratio has opposite and adjacent? Tangent. I'm going to have tangent of our angle, which is 30 degrees, equals the opposite over the adjacent, which is x over y. I'm going to put my big one over here because I'm running out of space, and I'm going to use all that space. The big triangle, help me write an equation. What do we got? Tangent of 60, right? From this angle you have the opposite, hypotenuse, and adjacent, and same thing, I'm crossing off the hypotenuse, so I have tangent of 60 degrees equals the opposite over the adjacent. Alright, here are some clues. Remember, we talked about how the trig ratio and its angle, they're married. What are they, class? They're not getting divorced. You cannot separate them. That is a clue. They are together. Okay, until you actually evaluate it. Alright. What we're going to do is, in systems, there's multiple ways of solving them, but we're going to solve them by substitution. What are we going to do, class? Substitution. If I can solve for y on this side, meaning get y equals, right, and everything else, and I can get this one where it says y equals and everything else on one side, then I can put them together, because they're both equal to y. Okay? So let's do that together. Down here, how do I get y by itself? Say again? Multiplying both sides? You can do that. We've also been doing what, class? So that's the same thing that you were talking about if I just multiply by y and then divide, right? So let's just do something we've been doing. Cross multiply. Y times the tangent of 30 equals x. And if I get tangent of, divide both sides by tangent of 30, don't worry, this might be the only longest problem of the year. We're left with what? Now, it looks like a calculator ready equation, but we can't really do much yet, right? Let's use a color we haven't used. How about blue? That says 30. Okay, let's go ahead and do the same thing for the big one now. Class, what do I do? Cross multiply. Class, tell me what to write. Y times tangent of 60. X plus 5. And what do we do to get y by itself? And then I have my calculator ready equation, or y solved by itself. Y equals x plus 5 over tangent of 60. Let's pick a color we haven't used yet. Alright, let's put the blue, this part, right next to this one. X over tangent of 30 degrees is equal to y. Basically what I'm doing here, in this blue here, I have y equals all of this, right? So if I see y, I can put y equals x over tangent of 30. Everyone say substitution.
Substitution.
That was my substitution. Right now it's just really heavy on the algebra. Okay, my goal is to get the x's on one side, and then I can solve for x. Okay? Right now I have two fractions set to each other. I have two proportions, therefore I can solve it by your best friend, cross multiplying. X times tangent of 60 equals, pay attention here, tangent of 30 and times x plus 5. We're okay so far? Alright, this is what I'm going to do next. I'm going to distribute the tangent of 30 to the x and to the 5. I'm going to go super slow here because this was like the number one common mistake over the past years in doing this problem. If I distribute them, here there's still what math operation? Addition. So in the end you will have addition. The reason why I say that is a lot of students will have turned it into multiplication. Why? Tangent of 30 times x is tangent 30x. And tangent of 30 times 5 is tangent of 30 times 5. And over here I still have x tangent 60. Alright, I'm going to subtract this term to the other side. And what I'm doing here is I'm getting the x's together. They were a lost couple, and now they're getting back together. Is that nice? So what I do to one side, I'm doing to the other. So now I have this expression, x times tangent of 60 degrees minus, let's put the x in front, x times tangent of 30 equals, these canceled, right? Tangent of 30 times 5. Put your finger on the greatest common factor on the left side. Class, they both have an x. So I factor out an x. We're almost done solving the problems of the world. And then I'm just trying to solve for x, right? What math operation is here? Multiplication. So I'm going to divide this whole thing. Now, pay attention. Here's another common mistake over the years. Students think, well, Mr. Ng, these are like terms, so I can subtract them. You cannot subtract angle measures. You cannot tell me this is tangent of 30. Everyone say no. Don't do it. So let's divide this whole thing out. Tangent of 60 minus tangent of 30. You guys still alive? Don't worry, the oxygen masks are going to be deployed. And then you're just left with x. Is that amazing? Just a calculator-ready equation. Tangent of 30 times 5 divided by tangent of 60 minus tangent of 30. Okay. If you are scared of putting all of that into your calculator, you could evaluate those separately, meaning you just type in tangent 30 and then replace it with a decimal. Okay? Let's say I want to eliminate kind of like potential difficulties. I'll just type in tangent of 30. And I'm going to get 0.577. We talked about earlier rounding to the nearest 4 decimals. So that is tangent of 30, and then I can put that same number, 0.5774, for tangent of 30. And I'm just going to get tangent of 60. 1.7321. And then if you feel comfortable now, then you can put in your calculator. So I have my numerator, 0.5774 times 5. Close my parentheses, divided by 1.7321 minus 0.5774. And x is equal to 2.5. Whew. Let's review, and then I'll show you guys some alternatives. First, we drew one triangle, separated into 2 triangles, realized what's in common is the purple, so I have to set them equal to each other, and then I'm just doing a lot of algebra to solve for x. Now, in this problem, did anyone see why this problem is so special? Besides that it's a long problem. Anybody? 2 variables, yes, that's new to you. But what's some old information? They're special right triangles. We could have used the 30, 60, 90s. Now, I will probably change these numbers so they're not going to be using special right triangles. Okay? All right. There you go.